Okay, we'll record in a moment, hopefully. Okie dokie, so let's go back to the regions of the brain. So, starting at the surface of the brain, the cerebral hemispheres, then the diencephalon, then the midbrain, pons, medulla oblongata, and the cerebellum. So what does that look like? So if we look at the top of the brain, we can see that there are arteries there, obviously, the longitudinal fissure. The cerebellum is down below the cerebral hemispheres. We have a right and left cerebral hemisphere. So we'll learn that the right and the left have different functions, and that's called lateralization. So if we look at a lateral view of the brain, you can see the central sulcus, and the precentral gyrus is where motor output after all the sensory information is analyzed in the postcentral gyrus. This is called the somatosensory cortex and the motor cortex. So information is passed up to these layers in the cerebral hemisphere. So we have the occipital lobe where the vision center is, the temporal lobe where the auditory centers are. So the occipital cortex is the visual cortex. Here's the cerebellum, which is called the little brain. Here's the pons and medulla oblongata. So the top of your brain is covered by a large connection of gyri, a gyrus. Each of these little projections is called a gyrus. Each little valley is called a sulcus. If you have gyri or sulci, you have the all of this cerebral cortex, which allows executive function, thought, speech, hearing, vision, balance. All of those things are ultimately analyzed. Vision in your visual cortex, the temporal lobe is where the auditory cortex is on both sides. So you should have a frontal lobe, a parietal lobe, an occipital lobe, and a temporal lobe. Take a cross-section of the brain. There'll be questions on the sheep brain that'll look very similar to this. So there's the frontal lobe, here's the corpus callosum, which connects the two hemispheres. The precentral gyrus is where the motor cortex is. The central sulcus is a large depression that separates the postcentral gyrus from the precentral gyrus from the postcentral gyrus. So this is the cerebrum. Then you're moving into the thalamus, the hypothalamus, which is the diencephalon. So the thalamus serves as a relay point for information to come through the ascending tracts up into the cerebral hemispheres and to send information out. So the thalamus is a relay point. The hypothalamus is very important for connecting to the pituitary gland, which attaches right here. A lot of regulation of breathing and respiration and heartbeat and the regulation of hormones takes place from the central nervous system into the pituitary gland. The optic chiasm is where the nerves from the back of the eye, the optic nerves cross on their way back to the in the occipital lobe where the visual cortex is. Then we have the brain stem with midbrain just below the thalamus and the epithalamus and so on, the hypothalamus. So we have midbrain, pons, and medulla oblongata. The cranial nerves, which we'll see in a moment, originate in the pons and the medulla oblongata and from the brainstem area. Okay, so 4 hollow chambers in the brain or ventricles. So the cerebrospinal fluid circulates through these ventricles of the brain and the central canal of the spinal cord to the subarachnoid space, and that fluid is constantly circulating. How important it is. If you ever have cerebrospinal fluid removed, you'll find you'll have enormous pain. The brain monitors the level of the cerebral spinal fluid, and it's very touchy when it loses volume. So the circulation of this fluid through ventricles and the central canal of the spinal cord through the subarachnoid space, then exchange with the bloodstream is very important. So if you look at the ventricles of the brain, you have the lateral ventricles, which are paired structures, and they communicate to the third ventricle, and then you have communication to the fourth ventricle through the mesencephalic aqueduct. Here's the pons, the medulla oblongata, the spinal cord. So notice that the lateral ventricles are enormous. They have the superior functions, superior locations, and a dip down and below the third ventricle, and so you have these connected cavities where cerebrospinal fluid is produced and circulated. So these ventricles of the brain that contain the cerebrospinal fluid are very important. The brain tissue relies on its blood supply and the cerebral spinal fluid circulation. So circulation of the cerebral spinal fluid, you have something called the choroid plexus, which is an accumulation of blood vessels where cerebral spinal fluid is produced. You have these various sinuses where circulation takes place in the arachnoid layer, and that information, that cerebral spinal fluid is also moving in and out of the spinal cord. So this is a connection between the third and the fourth ventricles. The choroid plexus of the fourth ventricle is an accumulation of blood vessels with the structure of the ventricles to produce cerebral spinal fluid. So the circulation of that cerebral spinal fluid around the brain and into the spinal cord and back into the lateral ventricles, the third ventricle and the fourth ventricle, the cerebral spinal fluid cushions and supports and is very important for brain function. So if you have this, here we have the dura mater inner layer, here we have the arachnoid space where the cerebral spinal fluid is circulating. And here we have the bone or the cranium, and this cerebral spinal fluid is going to be produced from the choroid plexuses of the brain and in all of these cavities in the ventricles, and it's going to be released from the arachnoid space into the superior sagittal sinus in between the dura mater. So what does the cerebellum do? The cerebrum. So let's stop there and go back here, stop recording,